So in this problem, which is number 31 from section 7.1, instead of looking at a set of numbers and putting an operation on them to form a group, we're going to start actually with a set of functions on the real numbers and put an operation on them, namely just regular composition of functions, and see if they form a group. So in this case, starting with any two real numbers, a and b, such that a is not 0, we build a function, we call it t sub ab, which eats a real number and spits out a real number, and it does it by taking the first real number, multiplying it by a, and then adding b. If we take all such maps, t sub ab, where a is not 0, and we impose the operation composition, the claim is that we get a group, even a non-abelian group. Well, the first thing is we need to make sure this really is an operation. That is, if you compose two of these functions, you again get a function of this type. That is something that's going to spit out essentially a linear function. So let's take a look. If I compose, say, TAB with TCD, where here the assumption is A and C are not 0, we evaluate it on some real number x. Well, the first time we get TCD of ax plus b. And then when we evaluate TCD on ax plus b, we get c times ax plus b plus d. And if we rearrange the terms here, we get cax plus cb plus d. And this is precisely t sub c a comma cb plus d. Okay. So this is again an element of our G, and so we really have a binary operation. We next need to check associativity, but that's not so bad here, because these are functions, and function composition is always associative. It doesn't matter what the functions are. So we're good to go on associativity. Okay, next we need an identity element. And, well, we could play as we have in the other videos and try to work out what the identity should be. But let's think a second. We're dealing with functions, right? There's a really good candidate for the identity function, namely the identity function, right? It's the function that does nothing. That's the one that takes x and sends out x at the end. And sure enough, that would work here, right? We could send x to x, a would have to be 1, and b would have to be 0. So our identity is simply going to be, well, let's see, we said a should be 1, and b should be 0. And since this is the identity function, you compose it with any other function, it must not do anything to it, we know we have the identity in our potential group. Okay, so finally we need to look for the inverse. So that means starting with some TAB, we need to find some other combination, A comma B, or in this case C comma D, such that when we compose it with TAB, we're10, get back this T10. So let's take this formula that we concocted. Let's move it up. Let's copy it. So we remember that TCD after TAB is the same thing as TCA comma CB plus D. And we want to have it come out to be equal to T10. Okay? That's the identity element. Okay, so that immediately tells you that CA is going to equal 1, and so C is going to equal 1 over A, and CB plus D is going to equal 0, so D will equal negative CB, and since C we already know is 1 over A, this becomes negative B over A. Okay, so this tells us that our candidate is going to be T 1 over A, comma, negative B over A. Now we know it's going to work in this order. Let's check the other order. If we do TAB after T, well now our C became 1 over A, and our D is negative B over A. Okay, our composition rule tells us we multiply the first two. So A times 1 over A is just going to be 1. And then it says you take the component the first component on the left multiplied by the second component on the right. So we're going to do A times negative B over A. And then we need to add the second component on the left, so we can need to add B. So A times negative B over A, that's just going to be negative B, plus B is 0. So we end up with T1, 0, which was our identity element. So we really have found the inverse. Okay, so this tells us we actually have a group structure, and we'd like to know whether we have an abelian group or a non-abelian group. The asymmetry of our composition law suggests this should be a non-abelian group. So let's just try sort of a pseudo-random example, something pretty easy to work with, and see if we have commutativity or not. All right, well, sort of the easiest things I could work with are things like T1, 0, but that's the identity, so I don't want to work with that. How about T1, 1? And then maybe I'll use well, I don't want to use 1, 0. How about 0, 1? All right, so the composition law tells me I multiply the first two components, and that just gives me 0. And then I take the first component times the last, that's 1 times 1, plus the second component here, that's a 1. So I get T0, 2. Now let me reverse the order. So T0, 1 composed with T1, 1. Again, I multiply the first two, and that's 0. Then I do the first times the last, that's 0. Plus the second over here, that's a 1. And so I get T0, 1. And these are not equal to each other. Okay, so this implies G is a non-abelian